know that is very well explained in the video. It will be shown to you. I will request Mr. Sir to show that video. Within that, Mr. Sir will provide you the assignments. So you are giving the manual. I have already explained you. So fill up those assignment data and assign data and complete the table, draw the graph and submit. It's a small experiment, so it should be finished at best 5 or 5:30. Mr. Sir.
हाँ सर स्टार्ट करो
हाँ वीडियो टा तो कंप्लीटली अपन लोग टाइप करते हैं तो टाइम में करो
ठीक है
Welcome you all, dear students, to our physics laboratory on the School of Applied Sciences, KIT deemed to be University. We are going to study now the characteristics of a photocell. This is the aim of our experiment. So this is the objective of our experiment, and here we have to understand the most important thing in this experiment, that is the photocell, which takes very important role in this experiment, and we will characterize it using this photocell. This is a photocell. As it is enclosed inside it, this metallic box, we can see this photocell which is enclosed inside this metallic box that we can't see. Now you can see here, this is an evaporated glass or quartz bulb which is completely evaporated. There is no gas inside it. In order to increase the current, we have to fill it with gas. But it is here, it is completely evaporated. And in this evaporated glass bulb, there are two electrodes. One is cathode, another is anode. This cathode, just it is a semi-cylindrical plate which is coated with some photosensitive material. And in this photocell, we have used cesium oxide. We know various alkali metals, those who are very highly photosensitive, like in sodium, lithium, potassium, rubium, cesium. These are all alkali metals which are high.
all of you please mute.
सर के माइक्रोफोन
सर के बैकग्राउंड से आ रहा है
क्यों सुना है
हैमरिंग का साउंड आ रहा है
Okay, now listen.
यस सर यस
Highly photosensitive, and these can emit electrons when high frequency light radiation is incidented on this metallic surface. So this is one of the electrode, cathode, and it emits electrons after light is incidented on it. Number two, that is another electrode, that is a platinum wire which behaves as an anode, which is kept just vertical to the cylindrical axis of this photocell, and it is sealed from all sides. So here we can see this black portion here, that is the metallic oxide. We can see here, this is the photosensitive material which is coated on this semi-cylindrical plate, and this is enclosed inside this metallic box. Only these two terminals, positive and negative terminal, comes out. That photocell, which is like this, is kept inside it, and we will characterize these photocells. We will find some characteristics using this photoelectric effect, because the experiment is based on photoelectric effect. So the principle of this experiment is photoelectric effect, and this photoelectric effect has been discovered by Heinrich Hodge. This is the first scientist to discover this photoelectric effect in 1887. And then after so many scientists like Leonard, Holbach, Thomson, Einstein came forward to improve this concept. So initially he has discovered this photoelectric effect. And we know this photoelectric effect, it is just a phenomenon of emission of electrons with high frequency light radiation is incidented on a metallic surface. Then this ejection of electrons starts, and in order to emit the electrons from the photosensitive material, we have to supply a suitable frequency, very high frequency. Below that, photoelectron emission stops, and that frequency we can say that is the threshold frequency. So we know the atoms are having outer cells having free electrons, which are very free. Free in the sense they are loosely bound, but they cannot escape from the metallic surface. So very interesting thing is that the outermost cells, which are having very free number of electrons, when the moment when they leave the surface, exactly at the same time the metallic surface acquires a positive charge which repels these free electrons to move forward. So there is a potential barrier. To overcome this potential barrier, these free electrons should have sufficient energy to just escape from the metallic surface. And this minimum energy required by the electrons to be ejected from the metallic surface, that is called work function. And this is denoted by W0 or phi0 sometimes, which is measured in electron volt. So this work function depends on the metal of the anode, that is the metallic surface must be of alkali metals, and the condition of the metal, the negative plate, this condition of the surface also it depends. So there are two conditions for this work function. One is the condition of the surface, metallic surface, and other is value of threshold frequency or the metallic surface. Unless it is alkali metal, it will not be ejected. So mostly these alkali metals are used in order to emit electrons in a large number. So in this way, the experiment is based on this principle, and mainly the experiment is electron emission. So this electron emission in this experiment will follow the electron emission here, but we know electron emission of our various types, that is thermionic emission, field emission, or cathode, cold cathode emission, then photoelectric emission, secondary emission. In this way, so many types of electrons emissions are taking place, but in this experiment we will study here only photoelectric emission. So this photoelectric emission will be studied here, where the emission of electrons takes place only when high frequency light radiation is incidented on the cathode surface, which is coated with a photosensitive material. So this photoelectric cell we are using in this experiment, it takes very important role, but it is of three types. This photoelectric cell is of three types. One is photoconductive cell, other is photovoltaic cell, and other is photoemissive cell. So in our experiment we will study photoemissive cell. That means the emitted electrons are flowing, accelerating towards the positive plate, and these electrons are called photoelectrons. Next apparatus what we require in our experiment. One is photocell, number 2 a trainer heat, number 3 source of light. So this one is the trainer, and there is an setup, that is arrangement which is made to study the photo characteristics. So this is the experimental setup to study the photoelectric characteristics or photo characteristics using a photocell. So this arrangement is made here. Here these are the two effects. One is effect of potential and other is the effect of intensity on photoelectric current. What happens to photocurrent when potential potential difference between the two electrodes changes? Similarly, what happens to photocurrent when intensity given to the source or intensity given by the source is changing? So this is the arrangement. Here we can see this is the window through which light will enter and it will be incidented on this metallic surface. So this is the cathode which is coated with a photosensitive material, that is cesium oxide. So this cathode here, as it is coated with a very highly photosensitive material, so what happens when light of suitable frequency, or you can say more than threshold value, is incidented on this metallic surface of cathode, then ejection of electrons starts. So in order to emit the electrons, this cathode or this photosensitive material should have sufficient energy more than the work function. This is condition number 1. Unless the energy of the electron is more than the work function of the metal, then ejection cannot take place. Similarly, the second condition is only when the light of high frequency is illuminated on the metallic surface more than the threshold value or threshold frequency, then only that energy will be acquired by the free electrons and it will emit. So these are the two conditions for emission of electrons which is taking place. And after electrons are emitted from the surface of this cathode, then they are accelerated towards the anode plate or the positive potential plate. This is called collector plate, called anode, and it will attract all the emitted electrons which are emitted by the cathode, and it will flow only when some positive potential is given to the anode. Then this flow of current is taking place in the outer circuit, and that can be measured in terms of microampere. So the current measurement can be done in order of microampere. This is the microammeter in the arrangement, and the measurement of photocurrent, which gives in microampere, gives an idea just the number of photoelectrons, how many photoelectrons are ejected from the metallic surface. That gives that idea after the measurement of this photocurrent. And the voltmeter is connected in the circuit, and a potential divider. This is a potential divider, and the potential difference in between these two electrodes can be measured using this voltmeter. Whatever potential is given to the anode, that can be measured using this voltmeter, and this voltage can be positive, can be negative as desired, because this anode plate can be supplied both positive and negative potential using this potential divider. So this photocurrent takes place in the outer circuit, and this cathode on the other side is connected to a high tension battery, which is written here, with which the potential difference between these two electrodes can be changed. So this arrangement is inside this strainer. Effect of potential on photoelectric current, this is the first characteristics that we will study here. So when this anode plate is supplied with a positive potential, then what happens? The photoelectric current changes drastically initially, then after it slows down, and finally it gets saturated. There is no photocurrent after a certain value of the potential given in between the cathode and the anode. So that is called the saturation current. So at that stage, almost all the electrons are attracted by the collector plate, which is emitted by the cathode. And if you go on increasing this potential, positive potential to the anode, photocurrents goes on increasing. This is number one. Number two, when a negative potential is given to the anode, what happens? This photocurrent gradually decreases, and at a certain value of negative potential, this photocurrent flowing through the circuit stops. There is no further photocurrent flowing in the circuit, and for which this photocurrent stops, that potential is called stopping potential. That is V naught, denoted by V naught, measured in volt. So here that circuit diagram is also depicted here on the top of the apparatus. That is, one is micrometer, other is the voltmeter, and which is connected already in the circuit inside. and this is a potential divider. We will go on changing the potential between cathode and anode using this potentiometer knob, and this is a key to start the circuit. And these are different terminals, positive and negative terminals, which are already inside the arrangement. So let us connect first, then after we will see the readings. So here we can see this is the microampere and it is connected to the circuit with this patch cord. So I am connecting one by one. Positive of the micrometer is connected to the positive terminal of the circuit. Similarly, negative terminal of the micrometer is connected to the negative terminal of the circuit. Positive terminal of the voltmeter is connected here. We can see the positive terminal of the voltmeter which is in the circuit. Then this photocell, it will be connected to the positive terminal. So this is clearly written here, photocell. The positive terminal will be just linked with the respective terminal of the photocell, and the negative one of photocell will be connected to the cathode which is in the trainer kit, and a negative terminal of the voltmeter will be connected to the negative terminal of the voltmeter which is in the circuit. So our connections over. In this way we will connect first as according to the circuit diagram given in our manual. Then we will keep the potentiometer knob at 0 position, completely in anti-clockwise direction before we start the experiment. There is a window of photocell and cathode is kept in such a way that it will face towards the source of light. Otherwise, proper incidence, proper illumination of light will not take place, so that emission of electrons will not be complete. So this window should be kept facing towards the source of light. Next is, this is the source of light which is having a bulb of 100 watts, and it should be kept facing towards each other with a proper distance, with a suitable distance. So if we keep the distance in between these two, we have to measure it. Suppose I want to keep the distance 10 cm. So after we keep a proper distance in between source and cell, now we will switch on this trainer kit, and we can see here both voltmeter and micrometer should be 0 before we allow the incidence of light on the photocell. Then after we will switch on the light source which will be incidented to the photocell, and we will see the changes. Now the photocell is incidented with the light, and we can see easily that as soon as the light is incidented on the photocell, immediately we got a photocurrent 2.4 microampere. Then we will go on changing the potential. Here the frequency of light radiation is kept constant and the intensity of light is kept constant. Only we are going to change the potential in between cathode and anode, and corresponding changes in photocurrent we will observe. So let us take the volt, 1 volt. So we can see the current is increasing. This is 9.5. Suppose I will keep a gap in between 2 volts, that is 2 volt. So I will go to 3 volt, keeping the gap 2 volt. So this is 3 volt. We can see the current is 16.3. Then 5 volt, corresponding current is 18.2. Then 7 volt. So gradually the photocurrent is increasing, and for 7 volt current is 18.8 microampere. Then 9 volt photocurrent is 19.3 microampere. Then 11 volt, so the corresponding photocurrent is 19.9. So here photocurrent is slowly changing. Initially it increases rapidly, then 13 volt and 20.2, then 15 volt, corresponding photocurrent is 20.5, then 17 volt and the corresponding current is 20.7. So if we go on increasing the potential in between cathode and anode, so we should not keep constantly illuminating the photocell by the source. You can see now it is already reached to 0 position, then we will switch off. So for a particular frequency of light radiation and at a constant intensity, the photocurrent versus potential is taken. So in this way we will increase the distance, that means decreasing the intensity of light. Suppose we will go to 20 cm by increasing 10 cm gap in between source and cell. Now the gap is more. I have increased 10 cm. If I see again for the same potential 1, 3, 5, 7, 9 like this, which is given to the anode, then what happens to the photocurrent? You see, now when the voltage is 0, the current is 1.2. So gradually it is decreasing because intensity of light decreases by increasing the distance between source and cell. So in this way our first part, that is effect of potential on photoelectric current, can be observed by plotting a graph. So here you can see easily from the table for a particular intensity of light by fixing the distance in between source and cell 10 cm. It is very obvious from the table that when potential goes on increasing in terms of 2 volt, then initially photocurrent changes speedily, then after slows down, and if we continue in this way it will be saturated after some time. So initially there was no voltage given to the anode, but we get a photocurrent 2.4 microampere. So it clearly indicates that there is no time lag in between the onset of photons and emission of electrons. and this time interval is of the order of a nanosecond or 10 to the power minus 9 second. It means within 10 to the power 9 second this emission takes place. So without giving any potential to the anode. Then when we increase the distance 10 cm, we can see easily that intensity gradually decreases. That is why photocurrent is gradually decreasing, because we have decreased the intensity of light by increasing the distance between source and cell. So if we go to the entire table, it is clearly observed that photocurrent is gradually decreasing with the increasing distance between source and cell. That means when intensity increases, photocurrent increases. So this experiment is taken only when the frequency of light is kept constant and for a particular intensity of light. That is the effect of potential on photoelectric current. Then we will come to the next part, that is the effect of intensity of light on photoelectric current. So here now we will go for the second part, what happens to the photoelectric current when the intensity changes. So here we can see the distance in between source and cell is 48 centimeter. So I will keep the potential here in volt, and we will take a set of observations of photocurrent with respect to the intensity of light. Now this voltage is kept constant and the frequency of light radiation is also constant. Then after I will go on decreasing the distance by 4 cm without tilting the source. It should be properly incidented to the photocell. So now it is 44, you can see this is 3.8. So here this is 3.2 initially, then when it decreases by 4 cm distance, then it becomes 3.8 for 44. So I will go on decreasing the distance in between source and cell, and I will go on watching the photocurrent. Then 36, this is 4.8, then 32, this is 5.6, then 28, this is 6.8, then 24, this is 8.6, then 20 centimeter, this is 11.1, then 16 centimeter, this is 14.0, then 12 cm, that is 17.9. So from this entire table we can easily see that when distance is gradually decreasing by 4 cm, the photocurrent increases, and when the voltage is kept constant, that is here 10 volt, similarly if we proceed for 20 volt, 30 volt, like this, then we will get this type of observations. When voltage is increased, this photocurrent gradually increases, and for a constant voltage in between two electrodes, by fixing the frequency of light, we are going on changing the intensity of light by changing the distances in between source and cell, then photocurrent gradually increases. So it clearly indicates that photocurrent is in proportion of intensity of light. We know that photoelectric current is directly proportional to the number of electrons emitted by the cathode or the photosensitive metal, but this number of photoelectrons is directly proportional to the intensity of light. So it is very much clear that photoelectric current is directly proportional to the intensity of light, and that is why we are getting a linear variation between photocurrent and intensity of light. So this is one of the law in photoelectric effect which is satisfied. So we will plot a graph taking photocurrent along y-axis and the potential along x-axis. That is, we will find the effect of potential on photoelectric current. So we have to focus the entire table here. Here we will see the minimum current is 0.8 and the maximum current is 20.7 microampere. Similarly, along x-axis we will take the potential. It is not very difficult because it is in terms of 2 volt. So easily you can take it along x-axis. Here there are 10 observations here starting with 0. So 1, if I take 1, then it will be 3, 5, 7, 9.
Mr. Sir.
So here it will be stopped. So with proper units we have to clearly.
मिश्र सर ମୁଁ ଭାବୁଛି ପିଲା ଗୁଡାକ ଫାଷ୍ଟ ଟେବୁଲ ଟାକୁ ଆଗେ କମ୍ପ୍ଲିଟ କରିଦିଅନ୍ତୁ ତାପରେ ଆମେ ଗ୍ରାଫ ଟାକୁ ଦେଖେଇବା।
ଆଚ୍ଛା ଠିକ ଅଛି ମୁଁ ଏବେ ପଜ କରିଦଉଛି ଆଉ।
ହଁ ପଜ କରିଦିଅନ୍ତୁ ମୁଁ କହିଦଉଛି ପିଲାମାନଙ୍କୁ। Students,
Yes, sir.
we are giving you maximum 5 to 7 minutes to complete the table. Do you need more time?
No, sir. No. No, sir.
So we are giving, it is now in my clock 3:44. Just at 3:50 again we shall start the graph. Start the video where it will be explained how the graph is to be plotted. Then again the second table we will give some time to complete. Again the second table graph. Is it clear? I think it would be better.
Yes, sir. Yes, sir. Clear.
So we will start the video again at 3:50. 5 minutes ପରେ ନିଶ୍ଚୟ ସାର୍ କରେଇଦେବା।
हाँ ठीक है।
नहीं 10 to the power -2. सर एक्सक्यूज मी सर।
Yes.
सर वो टेबल बनाने के बाद थोड़ा ग्राफ फिर से समझा दीजिए।
हाँ,
सर,
वही
ग्राफ
तो
में
बोला ना,
D1,
मैं
D2,
वही
D3
चीज तो बोल रहा हूँ कि तुम पहले टेबल को कंप्लीट करो उसके बाद हम लोग ग्राफ दिखाएंगे।
सर
हाँ
डी स्क्वायर को 10 to power -4 में लेना कंपलसरी है सर।
10 to the power -3 या 10 to the power -4, नहीं तो ग्राफ ड्रॉ करने में तुमको तकलीफ होगा।
10 to power -3 ले सकते हैं ना सर?
हाँ ले सकते हो, लेकिन
क्योंकि सर
नंबर
जैसे
नंबर-
मेरा रीडिंग है सर 4,
ठीक है, जो 10 to the power -4 में लेना चाहता है ले ले, जो 10 to the power -3 में लेना चाहता है ले ले। नंबर जो हैंडल कर रहे हो वो कन्वीनियंट फॉर्म में रहना चाहिए बस।
सर D2 का भी ग्राफ बनाएंगे ना सर, ग्राफ 1 में?
क्या D2 का मतलब तुम्हारा समझ में नहीं आया तुम्हारा बात?
सर जो पॉइंट हम लोग को ये
तुम
देना है
पहला
सर,
टेबल
D-
के बारे में, तुम पहला टेबल के
पहला।
बारे में बोल रहे हो, दूसरा टेबल के बारे में
सर
बोल रहे हो।
फर्स्ट थी।
फर्स्ट टेबल में तो जितना सारे डिस्टेंस दिया गया होगा सभी डिस्टेंस के लिए ग्राफ बनाएगा ना।
हाँ सर D1, D2, D3 तीनों का ना।
हाँ वो पूछी 1/d² का मतलब सेकंड टेबल तक वो चली गई है।
Yes, sir.
ମିଶ୍ର ବାବୁ
ହଁ ଆଜ୍ଞା
ଗ୍ରାଫଟାକୁ ଆଉ ଥରେ ଟିକେ ମୂଳରୁ ଚଲେଇ ଦିଅନ୍ତୁ।
ମାନେ କେତେ ବ୍ୟାକ୍?
ମାନେ ଟିକେ ସେ ଗ୍ରାଫଟା ଯୋଉ ପାଖରୁ ଆଉ ଥରେ ଡାଟାଟା ଗ୍ରାଫରେ ପ୍ଲଟିଂ ହଉଛି
ହଉ
କେବଳ ଗ୍ରାଫ part. All the students you mark now how this graph is to be plotted.
Intensity of light by increasing the distance between source and cell. So, if we go to the entire table, it is clearly observed that photocurrent is gradually decreasing. The cell is 48 centimeter. 6, then 20 gradually increases. So, between photocurrent and intensity of light, in proportion of intensity of light. We know that photoelectric current is directly proportional to the number of electrons emitted by the cathode or the photosensitive metal, but this number of photoelectrons is directly proportional to the intensity of light. So, it is very much clear that photoelectric current is directly proportional to the intensity of light, and that is why we are getting a linear variation between photocurrent and intensity of light. So, this is one of the law in photoelectric effect which is satisfied. So, we will plot a graph taking photocurrent along y-axis and the potential along x-axis. That is, we will find the effect of potential on photoelectric current. So, we have to focus the entire table here. Here we will see the minimum current is 0.8 and the maximum current is 20.7 microampere. Similarly, along x-axis, we will take the potential. It is not very difficult because it is in terms of 2 volt. So, easily you can take it along x-axis. Here there are 10 observations here starting with 0. So, 1, if I take 1, then it will be 3, 5, 7, 9, 11. So, here it will be stopped. So, with proper units we have to clearly mention the scale just at the corner of the graph sheet. Then after we will easily plot all the points for a particular distance. Suppose I will take 10 cm, then we can see this is 1 volt and this is 0 volt origin. So, for 0 this is 2.4, for 0 this is 2.4. So, the point comes here. Similarly, for 1 volt this is 9.5, and 1 volt if I take like this 8, 9, 10, 11, 12, 13, 14. So, if you proceed up to 21, then the next is 9.5. So, here the point comes with 1 volt. It is 9.5. So, in this way proceed by plotting all the points in the graph. We will see a graph will come like this, and we will freely connect. This is for a particular intensity of light. So, this is for a particular distance, suppose D1, which is given 10 centimeter. So, in this way all the points will be plotted because the entire range is taken here. We have calibrated all the axes according to the observations coming in the table. So, if we find this graph, it clearly indicates that the photocurrent gradually increases and gets saturated for a particular potential given to the anode. And it is very much clear that curve is coming and meeting at some point along y-axis. So it indicates that the photo emission is instantaneous. That means there is no time lag in between the emission of electrons and the onset of photons. So within 10 to the power minus 9 seconds that I have already told, emission starts. And if you go on decreasing the potential, then the photocurrent gradually decreases, and if we further decrease the potential, it will come down and the photocurrent stops. So this is for a particular negative potential, that is V naught, called stopping potential, and this photocurrent stops here. Similarly, we will get other curves by increasing the distance d2, that is 20 centimeter. So for 20 centimeter, you see the current is now decreased 1.2. So if you proceed like this, then another curve is coming, but they are meeting at this stopping potential point. So distance is gradually increasing, that means photocurrent is gradually decreasing. So it is very much clear from the graph that I1 is greater than I2 is greater than I3, that is the saturation current is gradually increasing when D1, if I take this is D1, this is D2 and this is D3, that is 10 centimeter, 20 centimeter and 30 centimeter. So when D1 is less than D2 is less than D3, then I1 is greater than I2, which is greater than I3. So by taking all the graphs for three different intensities, we can conclude in our experiment that photocurrent for a particular intensity of light gradually increases and getting saturated at some potential given to the anode, and all the curves are meeting to a single point on the negative side of the potential axis, and this indicates that stopping potential is independent of intensity of light. It depends on the frequency of light. So for all the curves we have fixed the frequency of light radiation constant. So this photocurrent is completely independent of intensity of light and depending on the frequency of light. So this is one of the characteristics that we conclude. Similarly, if I go to the second table, then we have to plot another graph. In the similar way, we will find a scale for x-axis and y-axis.
Can you complete the second table with 1 by d square, the last column?
Okay, sir.
कंप्लीट कर दो सर सुने
Sir, we can change the scale now, sir, accordingly.
You could finish the first graph or not? That is what I am asking.
Yes, sir, doing that.
All of you completed the first graph?
No, sir.
Then, okay, you finish the second graph, a second table.
Okay, sir.
Regarding second table, what is your query?
No query, sir. We have to take just 1 by d square.
So calculate 1 by d square, keep it in
Okay,
10
sir.
to the power minus 3 or 10 to the power minus 4 power.
Okay, sir. सर फ्री हैंड से बनाना होगा ना ग्राफ नंबर 1?
Yes.
ओके सर.
सर ग्राफ बना रहे फर्स्ट टेबल का सर, तो उसमें 26.3 है सर हाईएस्ट रीडिंग पर, ग्राफ में 26 तक ही आ रहा था सर, वो 0.3 थोड़ा सा आगे ले लेंगे तो चलेगा?
Points must be within the graph paper.
सर तो एक दो पॉइंट सर, अगर फिर वैसे अगर 2 का स्केल लेंगे तो सर तो फिर आधा ही ग्राफ यूज होगा, तो सर बोले 80% से ज्यादा ग्राफ यूज होना चाहिए इसलिए.
ठीक है, you can leave that.
ओके सर.
सर फर्स्ट वाले ग्राफ में सारा पॉइंट्स आएगा ना ग्राफ में?
सर डिफरेंशिएट के लिए सिंबल चेंज कर दे सर, D1 D2 D3।
क्या हुआ?
जैसे सर D1 D2 D3 के लिए डिफरेंशिएट के लिए सिंबल चेंज कर सकते हैं ना ग्राफ में? ओके सर।
सर सारा पॉइंट्स ग्राफ में होना है ना, ये वाले ग्राफ में?
सारे पॉइंट्स से कनेक्ट नहीं करना इन ए zigzag मैनर। यू ड्रॉ ए स्मूथ कर्व just
तो
like
सर
it.
स्मूथ कर्व होना चाहिए बस।
You may have to leave some few points.
ओके
सर स्मूथ स्मूथ कर नहीं आ रहा है सर।
ମିଶ୍ର ସାର୍
ଆଜ୍ଞା
ଏ ଆମର ଡିନ୍ ଟିକେ ଫୋନ କରିଥିଲେ ଯେ ମୁଁ ମଝିରେ ଟିକେ ଡିଷ୍ଟର୍ବ ହେଇଯାଇଥିଲି। କଣ ବର୍ତ୍ତମାନ ଚାଲିଛି କଣ ସାର୍?
ନା ଗ୍ରାଫ କରୁଛନ୍ତି ଫାଷ୍ଟ ଗ୍ରାଫଟା।
ଆଚ୍ଛା।
एक्सक्यूज मी सर।
हाँ बोलो।
सर जो फर्स्ट ग्राफ है सर उसमें स्मूथ नहीं आ रहा है सर, स्मूथ कर्व नहीं आ रहा है।
स्मूथ कर्व आता है या आपको फ्री हैंड ग्राफ ड्रॉ करना पड़ता है लुकिंग इनटू हाउ दी
सारे
फिटिंग कैन बी डन?
सर सारे
सर, free-
करने ना।
तुम ठीक से देख नहीं रहे हो, ठीक से प्लॉट नहीं कर रहे हो।
सर एकदम प्रॉपर प्लॉट है सर। सर एक बार देख लीजिए ना सेट 5 का सर कैसा ग्राफ आएगा।
सर सर
बोलो।
सर जो ग्राफ खिंचाएगा वो ऑलमोस्ट हम लोग एवरेज पे लेके खींचेंगे ना, मतलब जरूरी नहीं है कि सारा पॉइंट कनेक्ट ही करेंगे।
ठीक है, जरूर नहीं सारे पॉइंट कनेक्ट।
जी